We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Good morning friends, myself PATEL JIGNESH. I am Assistant Professor in Mahatma Gandhi Institute of Technical Education and Research Center, NAVSARI. Today we are talking about the PI controller, which is the part of module in advancement in measurement. So first of all, we have to discussing what is a controller. So basically we already learned about the P controller, D controller, I controller, proportional controller, derivative controller, integral controller. Now we already talk about the combination of proportional and derivative controller. Today we can discuss about the proportional and integral controller. So it can basically work on the same principle we already talk about, but at the same time, what is the basically known from this is the PI controller. We already talk about controller basically work on the reducing the error. Basically it can be reducing the error. So whenever we have some set point, we have to decide it at a time after processing that we can achieving some in the form of output. So this output can be not exact, we have to set point, either it can be more than that or either it can be lower than that, but if precisely we have to decide the set point, at that moment we completely try that we have to achieve the set point. So some of the in the automation, some of the controller will be provided which is to control this set point. Now in the form of output, likewise if we have to setting up the some pressure value, we have to achieve the value of 20 or either 100 psi and not more than that. So precisely it can be achieving that value. So controller basically we are achieving the value which can be set by us. So controller, we can see that in the previous one, what is the proportional integral controller. So first of all, definition of the proportional integral controller is produces an output which is the combination of output of the proportional and integral controller. So it's a one kind of combination where we are using the proportional and integral controller. Now we can see the one of the example in that we have set up one point over there. Now 75% is my achievement. So what will happen? We are processing this value, we can provide some raw material. We can say that in the cases of raw material, and we have to process that, and my set point is we are achieving the 75% my output in the form of production. 75 production I want it, not more than 75 and not less than 75%. So ultimately what will happen after processing, we are not getting the 75% results, but we are just achieving the 70%. So what will happen, output can be given the some feedback value to the this, we are providing some summing point over there. So whatever raw material we have to provide it can be from this raw material we are not getting the 75% production, but what will happen, we are just getting the 70% production rate. So it can be producing some difference, whatever the set point and what we have to achieve. So it can be create the error. So set point and process value, which is the given the difference, this one is a 5% which is the error. So ultimately by using of this controller we have to reducing the error. So proportional controller and integrated controller which can be reducing the error. By means of this combination we have to reducing the error. So this one is the PI controller where we are using this 5% to become 0%. So ultimately how it can be worked. So first of all we can go into its derivation. So this one is the combination of proportional and integral controller. So we can see that this one is the actuating signal UT. This one is my actuating signal, when we have to provide that is KPET and KI integration of ETDT. Now this one is my proportional controller and this one is my integral controller. So this one is the combination of P and I controller. So in the PI controller we can see that this one is the proportionality. So actuating as per definition of the proportional controller, we can say that proportional controller can be directly proportional to error signal, can be directly proportional. This one ET can be directly proportional to UT. So we are taking the proportionality constant. Similar way in the integrated integral controller we can take the actuating signal which is directly proportional to integration of ET or error signal, integration of error signal. So proportionality can be removed by this coefficient, integral coefficient Ki. So ultimately we can write this combination, we have to write in the PI controller. This one is proportionality and this one is integral controller. Now we have to combination that we can this one is that in the form of time domain, so we can ultimately we can convert it into the frequency domain. So we can take the Laplace into both sides. So UT can becomes US and this one is KPET can be KPES KI ET DT, which is the KI over 1 upon S. So it can be ET can be converted into ES. So ES will be becomes common over there. So we can write KP plus KI by ES. So what will happen now? We can need the transfer function for drawing the block diagram. So what transfer function, how can we write down? So output over input, which is the definition of the this transfer function. So ultimately actuating signal, which is the my output over there, and error signal which can be input in my this one. So output is the US and input is ES. We already seen that in the last diagram where we are producing the UT over there. So this one is my output when we are taking the just this part. So at that moment we can see that this one is my output and this one is my input. So we can see the derivation. Now this one is the US over ES, which is my transfer function, where we can write transfer function in the form of output over input. So this one is my transfer function Kp plus Ki by S for PI controller. So Kp plus Ki by S. Now that's all for today.